Welcome. This is part 4 of a video going over a network and route and switch networking project that we're working on. This part 4 is going to cover DHCP and NAT for IP version 4. So we're going to configure one of our routers to be a DHCP server. We're going to configure another one of our routers to perform NAT services. And then after we're done with that, we're going to lock down the routers and perform access control lists on the routers and some of their interfaces. Let's go ahead and get started on that. Taking a look at our diagram, we're going to go ahead and first configure router 1 as a DHCP server for our VLANs 31 and VLAN 33. So I'm going to open up router 1, and that's going to bring me right to I'm going to get to the command line interface, and I'll log on. There we go. So now I'm ready to do. Now there's some default settings I want to do, and I'll go ahead and reveal those as we go. And so first off, we are going to reserve an address block. So we're going to reserve the first. We're going to reserve a block of address for static configurations for VLAN 31 and 33. So you need to in order to do this, you have to use the exclude command. It's always a good idea to exclude the addresses you want in your DHCP pool before you turn on DHCP, because you don't want it to accidentally give out one of these addresses. So let's go ahead and do that. We're going to go to configure terminal. And DHCP is the IP command. So we're going to type IP DHCP excluded address, and we're going to go ahead and exclude 192.168.31.1, which is good because that's the router's interface, and we're gonna reserve the entire block 192.168.31.1 through 20. So I'm going to go ahead and block that one out as well. Okay, that's how you exclude addresses. Pretty easy to do. I also want to exclude addresses for the 33 network. So I'm going to do 33.1 and 192.168.33.20. So now I've excluded those addresses so the DHCP server won't accidentally give them out. We're now going to create DHCP pools. And DHCP pools are the pools of addresses used to assign out a specific network. So I'm going to name these pools. So we're going to go ahead and name one accounting and one engineering. Both of them are, so that's appropriate because VLAN 31 is the accounting VLAN. So let's go ahead and create our first pool. We type IP DHCP pool, and we'll just call it accounting, ACCT. Right? There you go. And now we are going to specify the network that we wanted to assign addresses to. So we're going to do network 192.168.31.0, and I'm going to give it a mask. There you go. That's how you do that. And now I'm going to, there's a few options I want the DNS server to give out. The first, I want it to give out a DNS server. So I'm going to type DNS-server 10.10.10.11. That's the DNS server. And I want it to give it a domain name as well. So in this case, we will use our sample domain name, CCNA skills-based-assessment.com. I think I did that right. I did that correctly. So it looks like the unfortunately for us, the packet tracer does not accept this command. So we're unable to do this in the packet tracer. So don't worry about setting up the domain DNS server or the domain name in this case, because the packet tracer does not come with that command. But it does probably give you the ability to do a default router. So let's do that. Default -router. And we're going to go ahead and type default -router. So I'm going to go ahead and put the default route of 192.168.31.1. And that sets up a default route. So we're not going to give it a domain name in this particular case because that command is not available. Okay? No big deal. So let's go ahead and move on to our next pool, which is engineering. So I'm going to type IP DHCP pool. Oops. And we're going to call this one engineering. Removing the vowels. There you go. So that's the pool there, and we're gonna specify the network address for this one. This one's 33.0, and we'll give it its mask here. There we go. And we're now going to give it a DNS server, just like we did the other one. And we're going to use the same DNS server in this case, 10.10.10.11. And we're going to give it a default router, which is the address of the router itself. That's it. That's how you configure your DHCP pools. DHCP is now enabled on those VLANs. When a computer requests an IP address in one of those VLANs, this DHCP server will respond, and it'll give out the options of the default router and DNS server. It will not give out addresses in the 1 through 20 pool, which we excluded. So I'm going to exit out of all this, and I'm going to copy, run, start. All right, let's now go ahead and configure. We're going to make router 2 a NAT router for both static and dynamic NAT. So I'm going to close that, and we're going to open up router 2. There we go. And I'm going to go ahead and log on. And we're now looking at the router 2. Now what we're going to do is we're going to create a user account that can be used. We're going to enable a couple of services. We're going to take a look at that, and we're going to create a static NAT to a particular IP address, and we're going to also configure an access control list. The access control list will enable dynamic NAT to a specific machine, and then we're going to define a pool of addresses which inside machines can use to get to the outside network. And then that's basically the process we're going to go through. So let's go ahead and take a look at how we can do that. So I'm going to go to router 2. I'm going to do a config T, and I'm going to create a local database user that I will use later. So I'm going to type username, and we'll call it web user. So I've created a web user with privilege level 15, and I've given that a secret password of Cisco12345. Now, if you really wanted to demonstrate that user account being able to log on via NAT to a web server, Cisco allows you to emulate a web server with the command IPHTTP server. Unfortunately, Packet Tracer does not support this. And you'll see when I try to type in and it doesn't support it. If it did support it, you would then type the command IPHTTP authentication local. And when you type this command, it would then use that local username you just created to authenticate when you hit the web server. That command won't work either because the HTTP command is not supported in Packet Tracer. However, I'm just demonstrating to you how you would set up a simulation of a web server if you actually didn't have a web server to use. So let's go ahead and type IPNAT inside source static 10.10.10.10. Basically what this is I'm saying I have an inside address 10.10.10.10. Remember that's assigned to my local loopback. And I want this to be mapped or translated to an outside IP address of 209.165.200.229. So I'm saying that the address 209.165.200.229 will be mapped to the IP address 10.10.10.10. There you go. That's basically how you make that happen. And now we're going to go to that local loopback address interface LO0. And I'm going to say IPNAT inside because I want this to be using NAT. And then I'm going to go to my outside interface, the one that connects to the internet. Just real quick, I'll show you that. Notice that this is the interface that connects to the internet. I'm going to make that the IPNAT outside. And the local loopback, I'm going to make IPNAT inside, just to show you what that looks like. So now I'm going to go interface G0/0, and I'm going to make this IP NAT outside, and that's how you configure NAT to work. Okay, that's NAT pretty much works now. It's on, meaning inside the local loopback is NATed to the outside, and I've got a static NAT created where anybody trying to hit that 209.165.200.229 address will be redirected to the 10.10.10.10 address. So that is working. Now I want to set it up to where I'm allowing certain people to use the NAT, and I do this with an access control list. So let's go ahead and take a look how to do that. So I'm going to type, first off, let me exit interface mode, and I'm going to type access dash list 1 permit. This is just a basic access list, a standard access list. And I'm going to type in the range I want to use this. So 192.168.31.0. So I'm saying anybody in the 31.0 network using the wildcard mask of 0.0.0.255, anybody from there will be able to use this NAT. So if they try to go out to the internet, they will be using my NAT pool, which I haven't set up yet, but I will set up the NAT pool after I'm done setting up the access list. You have to set up the access list before you set up the NAT pool. So there we go. Now I'm going to set up the second entry of my access list, and this time I'm going to do the 33 machines. So anybody in the 33 network will be able to use the NAT pool once I'm done setting up the access list. I also want to say anybody in the 4.0, 5.0, and 6.0 networks by using the mask 0.0.3.255. I'm basically saying anybody in 4, 5, or 6.0 networks will also be permitted to use this NAT pool. Now, I haven't given them permission to use the NAT pool yet. I've got to create the NAT pool. So now what I'm going to do is I'm going to type IP NAT pool, and I'll call this internet. So IP NAT pool internet, and I'm going to type 209.165.200.225. By the way, this is the address, the beginning or the start address of my pool, and then I'm going to put the end address of my pool. And I will give my net mask for this address range, which is 255.255.255.248. So this is the pool of addresses that I'm going to use to when machines need to go onto the outside network, they will request an address to use in their NAT. So this is the range of addresses they'll be able to use in network address translation. Okay. I either have a typo or I've got something dramatically wrong. So let me look at what that is. 209.1. Oh, yep, I do. I made a typo. So it's 209.165, and I did 168 here. So that wasn't good. So now it works. Okay, so now I'm ready to set up my. Now that I've set up my access list on my NAT pool, I need to link that NAT pool with the access list. So I'm going to type IP NAT inside source list 1. So that basically says on the inside NAT, I want it to use access list 1, and I want its pool to be internet. And that's basically how I link the NAT to its pool and to the access list. There, now you've pretty much turned on NAT. If you want to see how this works, let me just show you real quick. You can now type show IP NAT Translations, and this will show you that I have a static NAT, this global IP to this inside IP. If there's any dynamic translations, meaning machines have requested a pool address, they would also show up in there. You can also type show access lists, and you can see the entries for access list 1 of who is permitted to use the NAT pool. And then you can also type show run, and you can see all of your NAT creations, your NAT pool, where you've applied NAT to, and your access list in the show running configuration. When you're done with that, you can do copy, run, start. There you go. Now, PCA, kind of an important thing here. If I go down here to PCA, and I open up PCA, and I bring PCA open up here, a couple of things should be happening at this point in time. Notice that, first off, we want to make sure that PCA gets an address from DHCP. So I'll click on IP configuration and choose DHCP, and it's going to request an IP address. Because DHCP is set up on the router, it is now getting an address in the pool. Notice that it got 21 because that was the first available address after my exclusion range. Notice it also got the gateway and also got the DNS server. So that all worked correctly. I can also verify that PCC gets a different address from a different pool because it's in a different VLAN. So I'll go to desktop IP configuration and choose DHCP, and notice that it gets 33.21, which is exactly what I wanted it to do. Okay, so there you go. Now we can now go to PCA, and we will know that routing is working on router 1 properly, and that everybody's able to work if I'm able to ping that machine 192.168.33.21, and we'll see if it goes through the router and pings PCC. The first will time out due to an ARP timeout, but the remaining 3 works. Now that ARP is done, it won't time out again. Very good. Now, if I had my web browser working, which I don't, I could test that web user by logging on. However, I believe I should be able to go to this PC, go to the Internet PC, bring up the Internet PC, and it's got an IP address already configured. So I'm going to click on Command Prompt, and I should be able to talk to that 10.10.10 address, not by pinging 10.10.10, but let's see if it actually will ping the loopback address that I did the NAT through. So 209.165.200.229. Let's see if that works. And it does. So I'm able to ping the loopback address, that 10.10.10 address that is on the loopback of router 2, by pinging the NATed address on the outside. So now I know that NAT works correctly. If I had the HTTP web services running, then I could actually open up the web browser of the Cisco IP server, but I'm unable to do that. All right, now we're going to configure some access control lists to secure our routed environment a little better. We're going to do some basic ones and then some little harder ones. First off, I want to create an access control list that only allows router 1 to telnet to router 2. Because maybe I don't want anybody to telnet into router 2. Maybe I only want somebody coming in from router 1 to telnet into that. So that's one thing I want to do. And I want to name that access control in admin.management. Okay, I also want to apply that access control list to my console, my telnet ports, and I want to make sure this is working. So let's go ahead and do that as our first step. So I'm going to go ahead and open up router 2. So we're going to go ahead and open up router 2. There we go. And I'm already in my enable mode. So we're going to go ahead and I'm going to okay. Sorry, I was distracted there for a minute. I'm going to go ahead and add an access list by going to config T, and I'm going to type IP access list standard, because this is going to be a standard named list, and I'm going to call this admin-mgt, right? So I'm creating a standard access list. Remember, these are only one direction, and I'm going to permit a particular machine. In this case, I'm permitting, let's find out who I'm going to permit. I only want to allow router 1, and remember, router 1 is the IP address. In fact, let me just make sure. Router 1, I'll hover my mouse over here, is 12.1. So the IP address for router 1 is 12.1. So I'll bring this back over, and let's go ahead and do that. Access list standard, admin management, permit, and I'm going to say a specific host, and I want the specific host to be able to access it as 172.16.12.1. So that is the only incoming IP that will be able to use it if I apply this access control list. So I've now created the IP access control list. That did not work. Oh, okay. What you have to do is you first create the access list with the name. So IP access list standard admin-mgt. And then once you're in that named access list, the reason why this happens is when you're in a named access list, you can actually change the order of the access list. So you're going to type permit host, and then you can type in your IP. So it will not accept it as a single command. So it's actually separate commands. So there we go. So boom, now we've permitted that host. So we've now done with the access list. You can type exit, take you back to command mode. Now, we've now created the access list, but that's not good enough. We actually need to apply the access list to the interface that we want it to happen. In this case, we want it to happen on the Telnet ports. So we're going to go to line VTY 0 through 4. So we're going to apply this to all the Telnet ports, and we are going to apply this access list with the access class command. That's what applies the access list. And you have to spell the name exactly the way you put it in before, and then you have to give it a direction. In this case, it's a standard access list, so it'll only work in one direction, inbound, but you give it a direction, in this case, inbound. And now I've applied it. Now let's go ahead and make sure this works or got set up correctly. I'm going to exit out, copy, run, start. And I'll show you. If you type show access lists, it'll show you now you've got this standard IP access list applied, right? You can see that in there. If you do show run, if you go to your Telnet ports, you should see right there, access class. You can see the access list actually applied to the Telnet ports, right? So there you go. Now, if I were to go to, now I'm going to go ahead and close router 2, and I should know, if I open up router 1, and I go ahead and log on, oops, I have to type the password in, right? I'll go ahead and log on enable mode password here. Now I should be able to telnet into the IP address of router 2. So 172.16.12.2, and there you go. I'm telnetted in. So I'll provide my password. Boy, I keep typing it wrong. Anyway, so that's how you connect into it. So Telnet is working. I'm able to Telnet into router 2 if I wanted to. So there you go. That's how you basically configure a basic standard access list to function. All right, let's go ahead and move on to a little bit more complicated of an access list. Specifically, we are going to do an extended access list. We're going to allow web hosts to get into router 2. Because we want them to get into that static NAT into our fake web server 10.10.10.10, and we're going to apply this access list to the appropriate interface, and we'll make sure that it works. So let's go ahead and do that. I'm going to open up router 2, and I'm going to go ahead and go to enable mode, and here we are. So let's go ahead and talk about how to get this to work. First off, we're going to create the access list. So I'm going to type access-list. Now, extended access lists, IP extended access lists, use the number above 100. So I'm going to use 101. And I'm going to say permit. And now extended access lists have to permit based on the layer 4 protocol, in this case TCP. So I'm going to do TCP any host, and I'm going to type the outside global address 209.165.200.229, right? And I'm going to say I want this to be on or equal to the www port. Okay? That is going to be my first access list, and that did not work. Oh, because I was really dumb and I needed to be in the configuration mode. I thought that looked perfect. What was wrong with it? So All right. Well, I have to do this command over again. So I'm going to, which is okay, I guess, right? So I'm going to do access list 101 permit TCP any host 209.165.200.229 equal to port the www port. There you go. We now have an access list entry for an extended access 101. We also want to allow ping. So to allow ping, I type access-list 101 permit ICMP. This allows ping, any, and I'll say echo reply. So I'm going to allow pings to come back. So I can ping the web server still, because remember, my fake web server isn't actually working. The only way I can really test it is with ping. So I'm going to go ahead and allow that, and I want to deny everything else. So I'm going to do access-list 101 deny, and I'm going to deny IP any. So I've allowed everything, and then I'm going to deny everything else at the end. So there you go. That creates the access control list, which allows web traffic to my global NATed address, and it allows pings to that global ping replies from that global NATed address. Now I need to apply that to an interface in a direction. So we're going to apply it to our gigabit interface, which faces the internet. So I'm going to type interface G0/0, and then I'm going to type IP access group is the command to apply an access list to an interface. So I'm going to do IP access group. I'm basically grouping all the access list statements onto one interface. And the access list that I want to group is 101, and I want to do it in an inbound direction. So any traffic coming into the interface will be affected by this. I'm going to hit enter. That now applies the access list. That's it. That's all you do. So I'm going to hit Control-Z to break out and copy, run, start. That saves the configuration. Now we can test this. So first off, the first way to test is to do your show access lists, and you can see your extended IP access list has been created. It looks correct. You can now do show run interface G0/0, and I can see the it doesn't let me do that. I forgot. Packet Tracer doesn't support that. Just do show run, and you can see the gigabit. You can see your IP access group applied to the gigabit interface, which is what I wanted. You can also, and then finally, we'll close that, and we can open up the Internet PC. I'll bring Internet PC up here. I'll go to the command prompt, and I can try to ping that IP address again. Oh, sorry, wrong address. 230, I believe it was. Yeah, so 230 was the correct address to ping, and so you can see it is allowing pings. I'm able to ping the address. So there you go. So I'm able to ping the router's address because the access list still permits it. But it will not permit ping to anything else, and it won't allow any other traffic to go through the router because I'm only allowing www traffic or HTTP traffic through that access control list. All right, that's pretty much it. I think that's all I want to show you. Let me see if there's anything else I want to do. Nope. That's it. Oh, by the way, once you've done that ping, if you wanted to see something, you can go to your router too, and in the prompt here, you can do show IP NAT Translations, and well, they've already cleared out, but you can see translations coming from different machines. You could even have one of your machines try to get out to the internet, and you would see that. Let me see if I can actually show you to do that. How would I do that? I want let's do PC1, PCA, and I want PCA to ping 209. Okay, 230. All right, there we go. 230 was my own IP address. That was strange. I did that wrong. All right, so let's go ahead and do that. I'm going to go ping 209.165.200.230. And I'm getting replies back from 230. because my IP access list allowed ICMP echo replies to come back to the interface. Now that I've done that, I can go to router 2, and I'm going to go open up to router 2. Now I can show IP NAT translate. That's not working. We should see our translation in there. It's not showing that up. Maybe it's not actually working because yeah, because we're kind of simulating an internet. I don't know if it's actually going to work. So anyway, the idea is that if this was working beyond the simulation, and this was like the real internet on the other side, then you would see NAT translations coming through from that PC. This isn't exactly working the way I intended it. That's okay. The concept is the same nonetheless. So there you go. By the way, my access list is incorrect if I wanted to allow people to ping that web server. So I'll show you why that is. Show access lists. Notice that I'm permitting TCP, but I'm not permitting ICMP to that machine, right? So to do that, okay. Okay, I'm going to remove, so I've done a no. I've no access list 101 deny IP any. So I've removed that entry. And now I'm going to add another entry. This one I'm going to do, I'm going to type access list 101 permit. And we're going to say ICMP to any host 209.165 from any host to 165.200.229. So now I'm allowing anybody to ping that machine, and now I'm going to go ahead and do my deny at the end. So access list 101 deny IP any. So now I've blocked that out. I'll hit there, and I'm going to show my access lists. And let's see if that looks correct. It is correct. The problem is I don't have the... when I did the no command, it blanked the whole thing out. So let's do it again. Let's do it better. Let's do it correct. So no access list 101. All right. Now let's exit out. And I'm going to show access list. Okay, access list 101 is gone. And now I'm going to do access. Let's do this again. Access. Actually, I think I have it already in here. There we go. Access list 101. I'm going to permit web traffic. Now I'm going to permit ICMP to that machine. Now I'm going to permit echo replies. Well, we'll just retype it again. Access list 101 permit ICMP any echo reply. There we go. That does that. Now I can go ahead and do my deny at the end. So I'm going to do deny any. All right, great, got it. So now let's exit out. And I'm going to do show access list. Got to type that correctly. Boy, I'm not spelling very good. There we go. Now it looks correct. Good. Copy, run, start. And now I'm going to open up the Internet PC, and let's get this correct this time. So we're going to open up our command prompt, and now let's ping the 229 machine, and we're able to ping now. Notice that I was not able to ping before because the access list was blocking it, and now I am able to ping. 230 was my own IP address. I just made a mistake. So 229 is our global NAT, and now I'm able to ping it, whereas before I was not able to ping it. So there you go. That's pretty much how you accomplish that. So that's how you configure your NAT. That's how you can. Just to recap what we did. We configured router 1 to be DHCP. We configured router 2 to allow NAT. We did a static NAT to our fake web server 10.10.10.10. We also created NAT pools to allow the machines in VLAN 31 and 33 to go out. Even though NAT translations don't work quite right in the simulation, we did set that up correctly. We also configured access control list to prevent anybody from telneting router 2 except for router 1. And we also we allowed only internet PC. We basically said only www and ICMP traffic can hit our 10.10.10 address. And anybody who wants to ping out can get a ping back from the internet because we allowed ICMP echo reply. That's pretty much it. Thank you very much.